So now we'll start with root mean square of a waveform. Okay, so let's see what is root mean square. So by definition, the formula of a root mean square is waveform is 1 by period integration of 0 to period. Here the function value similar to the average, but here we'll square it, means the square term, square dt. Okay, this is the square term. And when 1 by period, whenever we use the term 1 by period, we basically what we do is that we are taking the average. Okay, so this is basically the mean, and we'll keep with a square root above it. So this is the root. Okay, basically the root mean square. Fine. So let's see if I have any periodic waveform or maybe a DC signal, how to find the RMS value. So first case, let's find the RMS value of a sinusoidal signal. Okay, of a sinusoid. This is how a sinusoid will look like. A minus a. Suppose this is the function of omega t. Okay, this is pi twice pi. So what was the average value of the sinusoid? It was 0. So let's check what is the RMS value of a sinusoid. Okay, to find the RMS, what we will do is this 1 by period. What is the period here? This is the period. Twice pi is the period. 0 to twice pi. What is the value of the function? Formula of the function, it is sine a omega t. Okay, we can write it here, sine a sine omega t to be whole square and d omega t, and we'll place a root over it. Okay, let's break it down and see what we come across. So what is sine squared theta? We can write it as 1 minus cos 2 to theta by 2. So we will use this identity. One minus cos 2 theta by 2 d omega t, place a root. We can take 4 or 2 outside. Sorry, this will be theta and this will be omega 2. Okay, so if we break it down further, what is the integration of d omega t? It is simply omega t, and it will go from 0 to twice pi. And what is the integration of cos 2 omega t? Integration of cos is sine, we can write twice omega t, and this 2 will have in the denominator, and it will go from 0 to twice pi. So a square by 4 pi, it will be twice pi minus half sine of 4 pi minus sine of 0. So sine of 4 pi is 0, sine of 0 is 0. So this term is basically 0. So we'll only have this term. So pi cancel, 2 cancel. We have n by root 2. Okay. So the RMS value is of a sinusoid is a by root 2, while its average value was 0. Fine. Let's consider another signal. Let's consider a DC. Okay. So what will be the RMS? Again for DC, the period we will keep it as t only, 0 to t ft whole square dt root over. So it will be 1 by t 0 to t. What is the value of ft over 0 to t? It will be constant as a. It will be a square dt. A square by t integration t by dt. It will be integration of dt is t from, and it will go from 0 to t. It will be a square by t root. It will be a. Fine. So the RMS value of a constant or a DC value is the value of the DC itself. See, also the average value is also the same. Means for a DC, the average and RMS value is same. So let's consider another signal. Let's consider full wave rectified output. So in case of full wave rectified output, basically this ft will be the value of the voltage or with the current. So here in general we are writing ft. Maximum value is a omega t by twice pi. This is the period. So RMS value will be 1 by pi 0 to pi a sine omega t whole square d omega t. Okay. So similar as before, the steps we considered before, we need to take the same steps. We need to break sine square omega t is 1 minus cos 2 omega t by 2. So like this, if you continue, so you will get the RMS value as a by root 2. Fine. So what will be the RMS value? We consider a half wave rectified output. Here the time period is twice pi radians. from 0 to twice pi ft whole square. So we always keep writing ft to be omega f. We'll break it into parts. 0 to pi a sine omega t d omega t plus pi to twice pi basically from t pi to twice pi, its value is actually 0. It is 0, right? Obviously this one is 0. I forgot to write the whole square. 1 by twice pi a square okay. So similarly if you continue, so at last we will get the RMS value as a by 2. If you continue to get this value a by 2, so this RMS value of a half wave rectified output will be a by 2. Okay. So next, which case we can take? And let's take this sawtooth. So RMS value will be, this is the period 1 by t 0 to t, and in previous video we already saw that from 0 to t ft was a by t into t. This was the equation of the function from 0 to t. So we can write it t dt whole square t square integration of t square dt 0 to t. What is the integration of t square? It is t by t cube by 3, and it will go from 0 to t. A square by 3, and 1 by 3 you can keep outside, it will be t cube. So t cube cancel, and it will ultimately get a by root 3. Okay. Fine. Okay. Likewise, you can calculate the RMS value of different kinds of waveform. So let's do a quick comparison of the various types of waveform. Fine. So comparison of average and RMS value of different kinds of waveform. So first, sinusoid. So what is the RMS value of this? It will be a by root 2. What is the average value? It will be 0. Okay. For DC, What is the RMS value? RMS value is A, and what is the average value? It is also A. Fine. What about half wave, a full wave rectified output? RMS value will be A by root 2, it will be A by pi. Twice A by pi. Fine. Half wave rectified output. What is the average RMS value? It will be A by 2, and what is the average value? A by pi. Fine. Next, let's take the square wave. What will be the average value of a square wave? Average value is 0, and RMS value A by root 2. What about sawtooth? What is the average value? Average value was A by 2, and if you calculate the RMS value, you will get A by root 3. Similarly, for if we take triangular kind of waveform, here also the RMS value you will get A by root 3, and the average value will get A by 2. Fine. Okay, so we have discussed about the average and the RMS value, how to find the average and RMS value of current or voltage, basically for any waveform. So after that we will check why this average value we understand, but why we need the RMS value. So we'll discuss about that.